Hi, Chris Good here. We're going to do a practice homework problem. This is number 20 from the end of the related samples repeated measures t-test, and I've copied the data here onto my paper, and I'm just going to read through the question right now off my iDevice. A researcher uses a matched samples design to investigate whether single people who own pets are generally happier than singles without pets. A mood inventory questionnaire is administered to a group of 20 to 29-year-old non-pet owners and a similar age group of pet owners. The pet owners are matched one-to-one with the non-pet owners for income, number of close friendships, and general health. One of these things that they matched them on is kind of related to what they're interested in, is their mood inventory, and that's the close friendships that they have. It would have been better if they had matched on something more closely related to the mood inventory questionnaire, but let's not quibble about that. What we want to know is whether there is a significant difference between pet owners and non-pet owners. And we're going to use the related samples t-test, because even though these aren't the same people, they've been matched on a variable that makes sense. And so we're going to use this as a match design, and we're going to use that related samples t-test since they were matched before the study began. So I'm just going to quickly compute the different scores by subtracting the scores of the non-pet owners from the scores of the pet owners. So 14 minus 12 is 2, 7 minus 8 is negative 1, 13 minus 10 is 3, 9 minus 9 is 0, 13 minus 7 is 6, and 12 minus 10 is 2. Should be pretty simple to calculate the mean of the different scores. That's just the sum of the different scores over the number of different scores. We have 6. And so that would be 2 minus 1 is 1, plus 3 is 4, plus 6 is 10, plus 2 is 12. So that's 12 over 6, or a mean difference score of 2. Alright, so our mean difference score is 2. We're actually quite close. But we're going to do all the steps that we usually do in a null hypothesis test. So we're going to start with stating the null hypothesis, which is that the population mean difference score is 0. Okay. Next, we're going, it says use alpha. They've already done that for us. Alpha is 0.05. And we're going to use two-tailed test. And so we need to find the t-crit for 6, sorry, that 6 minus 1 is 5 degrees of freedom, right? Because we have 6 different scores, so degrees of freedom are 5. And the t-crit for 5 we're going to have to look up in our t-table. So let's go to a friendly t-table. I like to keep mine in my Evernote. And open that up. Oh, that's the F table. We're not there yet. Let's do the T table. There it is. Okay. So proportion and two tails combined is 0.05, and we're looking for 1, 2, 3, 4, 5, 6 degrees of freedom. So I get plus or minus 2.447. Plus or minus because it's two-tailed. All right. There we go. Back to the problem. Now, we need to calculate t. T, for the related samples t-test, is pretty simple. It's the mean difference score minus our hypothesized population mean difference score, sorry about that, divided by the estimated standard error of the mean difference score. Well, we've got this part. This part we got from our null hypothesis up here, so all that remains is this. That estimated standard error of the mean difference score is equal to the square root, right, of the sum of squares for that mean, for those differences, divided by the number of differences that we have, which is 6. All right. The sum of squares, that sum of squares, right, is, sorry, that's the variance of the different scores over the number of different scores. The sum of squares we need to get that variance of the different scores, which is the sum of squares over the degrees of freedom. The sum of squares is equal to sum of those squared differences minus the square of the sum divided by the number of different scores. Okay, I'm just going to make another column here, get my d squares really quick. They're pretty small numbers, so I can do this in my head. It's 4, 1, 9, 0, 36, and 4. I'll sum those all up. So that's 36 plus 4 plus 1 plus 9 plus 4. So I get 40, 54. And remember to subtract the sum of all of these, which was 12. We'll square that. Divide by the number of them, that's 6. So that's 144 over 6. So that's 54 minus 24, or 30. Alright. 30 for the sum of squares. We'll pop that in here. 30 divided by the degrees of freedom. Don't get confused between your n and your degrees of freedom. Degrees of freedom here is equal to n, the number of different scores, minus 1. 6 minus 1 are 5. So sum of the variance then is sum of squares over 5, or 30 over 5, which is 6. So now we can plug that in here to the estimated standard error, that mean difference score. That's going to be 6 over the number of different scores, which is 6. Well, they make it easy for us, don't they? That's equal to the square root of 1, or 1. So, in the end, t is equal to, and I'll write that out again here, t is equal to the mean difference score minus the hypothetical population mean difference score of 0 divided by the estimated standard error of the mean difference score. That's equal to our mean difference score, which is 2, right, divided by 1, or 2. Let's draw that normal distribution of the t distribution here, right? And I'm going to draw in the shaded regions of our critical t values, 2.447 and minus 2.447. Shade those regions. We'll draw a little line here. Where is our t value? Where is 2? Well, it's closer to 0 than our critical value. That's our t. So it's not in the shaded region. The correct decision here, step 4, is to fail to reject. And all we can really say about this is that when it says the other part of the question is write a sentence describing the outcome of the hypothesis test. All we can write here is that we failed to detect a difference in mood a significant difference between pet owners and non-pet owners. I'm going to write the full report for t here. It's t with 5 degrees of freedom is equal to 2. And we know that p, because we failed to reject, all we can say about p is that it's greater than the alpha that we chose. It's greater than 0.05. Alright, and that's problem 20 from the Independent Measures t-test chapter in your text.